Have you ever stared at like a huge document? Maybe it's a massive research paper, 194 pages for a meeting, or maybe you're just really curious about something complex like AI, but just don't have the time to wade through it all.
Oh, yeah, that feeling of wanting the knowledge but needing it efficiently.
Exactly. You want to be well informed, get those aha moments, but without drowning in text. We totally get it.
It's about grasping the essence quickly, isn't it?
Hmm.
Pulling out the key stuff without reading every single word. You want the core insights, like distilled.
Precisely. And that's what we're here for today. Think of us as your personal information trainers for this deep dive.
Your guides through the data jungle.
Yeah, I love that. We're diving into something called mastering ARG systems. That's retrieval-augmented generation. It sounds technical, but we'll break it down. The goal is to see how this AI tool, RAG, can seriously change how you handle information overload and, actually learn stuff faster. We'll simplify, clarify, and hopefully give you those crucial takeaways.
Sounds good. And to really get RAG, we probably need to start with the basics. Large language models, LLMs.
Right. Everyone's talking about them.
They are these incredibly powerful AI programs, right?
Yeah.
They've been trained on just unbelievable amounts of text data. Think books, articles, websites, conversations, petabytes of it.
It's mind-boggling how much they process.
It really is. And through all that, they learn to spot really complex patterns in language. That's how they generate text that sounds so human, so relevant sometimes.
They're amazing, no doubt. But, and this is where it gets tricky, they have these, well, blind spots. Big ones sometimes.
Yeah, the hallucinations, as people call them.
Exactly. Like you ask for a dinner recipe and it confidently spits out a lunch recipe. That's an input conflicting one.
Or it just brings up something totally random, like steak, when you weren't talking about food at all.
Right, the context conflicting type. And then my favorite, the fact conflicting, where it just gets basic facts wrong, like saying tomatoes are bursting with calcium.
Which they definitely are not. And it's key to remember, LLMs aren't really understanding like we do. They're pattern matchers, predicting the next likely word.
So if the pattern leads them down a weird path.
Exactly. If your question isn't super specific, or if the data they learned from had errors, they can just invent things that sound plausible but are totally wrong. The source calls it confabulation, actually.
Confabulation.
Okay.
And it's not just making things up, is it? There's the whole knowledge cutoff issue.
Oh, absolutely. That's a huge limitation. An LLM only knows information up to the date its training data stopped.
So if it was trained up to, say, 2023, asking about last week's Premier League winner, forget it.
It just wouldn't have a clue. Its knowledge is static, like an old encyclopedia.
Yeah.
And you can't just constantly retrain these enormous models with fresh data. It's incredibly expensive and time-consuming.
Right. So they're stuck in the past, information-wise.
Pretty much.
Yeah.
Which is a major problem if you need current, accurate info for, real-world stuff. They need something more than just their internal memory.
Okay, so this is where RAG comes riding to the rescue, right? Retrieval-Augmented Generation.
Exactly. This is the solution. Think of RAG like giving the LLM an open book exam.
Okay, I like that analogy.
Instead of just relying on what it memorized during training, RAG lets the LLM look up information from your specific sources right when you ask the question.
Ah, so it's using external, up-to-date info.
Correct. Or at least information you provide and trust. This makes its answers way more accurate, current, and grounded in actual facts you've given it. It tackles those hallucinations and the knowledge cutoff problem head-on.
Giving you more control, basically, custom knowledge.
Precisely. You're augmenting its built-in knowledge with your specific data.
Okay, so how does this RAG system actually work? You said it's a 3-step process.
Yeah, it's quite elegant, actually.
Yeah.
Step 1 is all about building your knowledge library. So you take your documents, like that big 194-page PDF.
Our example document.
Right. And you first encode them. You convert the text into a numerical format, these things called vectors or embeddings.
Numbers representing meaning.
Exactly. Think of them as mathematical fingerprints that capture the meaning, the concepts, not just the words themselves.
So it's searching for concepts, not just keywords. That sounds much more powerful. Can it pick up on, like, subtle ideas?
It absolutely can. That's the beauty of it. These vectors then get stored in a special kind of database, a vector database. It's built specifically for searching based on this semantic similarity really fast.
Faster than traditional databases for this kind of search.
Way faster for meaning-based similarity searches. And crucially, each vector keeps a link back to where it came from the original source document, maybe a page number or URL.
Ah, so you can check its work, verification.
Exactly. Builds trust, enables transparency. You always know where the info came from.
Okay, library built. Vectors stored. Step 2. What happens when I ask my question?
Right, step 2, the smart search, or query and retrieval. When you ask a question, your question also gets turned into a vector using the same encoding method.
Okay, so the question and the document speak the same numerical language.
Precisely. Then the system compares your question's vector to all the vectors in the knowledge library. It's looking for the closest matches in terms of meaning.
The most relevant chunks of text.
Yeah, maybe it finds the top 5 or top 10 most similar chunks. And again, it remembers the source for each chunk.
And then step 3, the answer.
Step 3, augmentation and generation. This is where it all comes together. The LLM gets your original question plus the relevant chunks of text it just retrieved.
Okay.
And it uses both of those things to generate the answer. This is the augmentation. The retrieved info enhances or augments the LLM's own ability to generate text.
So the answer is much more specific, contextual, and based on the documents I provided.
Exactly. Not just its general knowledge. And you still get those source links, so you can see why it gave that answer. Think about customer support chatbots, and they can pull precise answers from company manuals this way. Always accurate, always aligned.
That's a really clear breakdown, thanks. But it sounds almost too neat. What if the information RAG retrieves is, wrong or biased? Does RAG check that?
That's a really sharp question, and you've hit on a key point. RAG is a framework, not magic. The quality of the information you feed it absolutely matters. If you give it garbage, it might retrieve garbage.
Garbage in, garbage out. Still applies.
It does. And this is where how you ask the question, your prompt, becomes super important. These are the coaching styles we mentioned.
Right.
Yeah.
Ways to guide the LLM even when the retrieve stuff isn't perfect.
Exactly. Different prompting techniques can help the LLM reason better, focus on the right details, or even verify information, significantly improving the final answer quality.
Okay, let's get into these coaching styles then. Our workout plan for the AI. First up, chain of thought, or OT.
Right, ThoT is like asking the LLM to show its work. You guide it through logical steps.
So for that apple problem, cafeteria had 23 apples, used 12, bought 6 more, instead of just guessing the final number.
You'd prompt it to break it down. Okay, start with 23. Subtract 12. What's the result? Now add 6 to that result. What's the final answer? Step by step.
23 minus 12 is 11. 11 plus 6 is 17. Got it. And the value isn't just the right answer. It's seeing how it got there.
Exactly. That transparency is huge, especially for complex problems or things where you really need to trust the reasoning, not just the final output, like in finance or medical fields.
Makes sense. Any downsides to ThoT?
Well, if one step in the chain is wrong, that error can mess up everything that follows. So it works best for problems that neatly break down into sequential steps.
Okay. Next up, thread of thought, ThoT. This sounds different.
It is. ThoT is your friend when the information RAG retrieves is messy, jumbled, lots of irrelevant stuff mixed in, which happens a lot with real-world data.
So if the search pulls back paragraphs with bits and pieces of useful info scattered around?
Precisely. Instead of just giving the LLM the whole messy pile, you tell it to go step by step through the retrieved context. Summarize this bit, analyze that bit connected to the question, then synthesize an answer.
Like cleaning up the information stream first.
Yeah. So if you ask where was Reclam founded, and you get back text mentioning Carlsbad, but also lots about intellectual circles and publishing history.
Well, ThoT helps it focus.
Right. It processes each piece methodically to isolate the key fact. Founded by Anton Philipp Reclam in Carlsbad, it structures the processing of noisy information.
Okay, that's useful. Then there's chain of con notes?
Yeah, this one's about getting the LLM to summarize first. Before writing the final answer, you ask it to generate concise notes or bullet points based on the retrieved documents.
Why do that?
It forces the LLM to explicitly identify and focus on the most important details. Plus, you get to see the notes, which adds transparency. Imagine asking, when was Deadpool 2 released? And the retrieved info has conflicting dates.
Okay.
With Con, the LLM might first generate notes like, source A says June 1st, 2018. Source B mentions May 18, 2018 due to rescheduling. Then using those notes, it synthesizes the final answer, clarifying the change.
So it highlights discrepancies and resolves them based on the notes. Neat.
It's great when having a clear summary of the key facts is just as important as the final answer itself.
All right, this next one sounds really clever. Chain of verification, COVE. Self-editing AI.
Pretty much. It's a fascinating approach. The LLM first drafts an answer like it normally would.
Okay.
Then it generates its own questions to check the facts in its draft answer. Questions like, is statement X true? Or what is the evidence for claim Y?
Seriously, it questions itself.
Yep. And then it takes those verification questions and runs them against the knowledge base, the vector database, to find answers.
Wow.
Finally, it revises its original draft answer based on the results of its self-verification. So if you asked, name politicians born in NY, and it initially includes Hillary Clinton.
Who was born in Chicago.
Right. Cove would prompt it to ask itself, where was Hillary Clinton born? It finds the answer Chicago, realizes its mistake, and removes her from the final list.
That's like a built-in fact checker. Really boosts reliability.
Significantly. It's fantastic for applications where you absolutely need high factual accuracy.
Okay, 2 more prompt styles. Emotion prompt. Adding feelings.
Sort of. It's simpler than it sounds. You just add a little phrase expressing some emotion or emphasizing importance to your prompt.
Like what?
Instead of just giving me presentation tips, you might say, gosh, I'm feeling really overwhelmed by this presentation. It's super important for my career. Can you give me some tips?
And that helps.
Research suggests it can, surprisingly. It seems to nudge the LLM towards maybe a more empathetic or comprehensive response. Like it makes the task seem more significant.
Huh. Interesting psychological trick for an AI.
It is a bit weird, but apparently effective sometimes.
Okay, last one. Expert prompt. This sounds more straightforward.
It is. You basically tell the LLM to act like an expert in a relevant field before you ask your question.
So role-playing.
Exactly. Instead of asking generally, describe an atom, you'd say, you are a leading physicist specializing in atomic structure. Describe the structure of an atom.
And it gives a better answer.
Typically, yes. A much richer, more detailed and nuanced answer using appropriate terminology and focusing on aspects relevant to that expertise, forces, shells, chemical significance, etc. It accesses and presents information from that specific viewpoint.
Like setting the context for the level of detail you want, giving your personal trainer a specific goal.
That's a perfect analogy. Train me for a marathon versus help me get fit. You get a more tailored result.
These prompting techniques are powerful, but they all rely on having good information retrieved in the first place. Which brings us back to how we get that 194-page PDF into the system effectively. Let's talk about chunking.
Yes, the art of breaking down information. Chunking is fundamental to making RAG work well. It's simply the process of splitting your large documents into smaller, manageable pieces or chunks.
Like chapters or paragraphs?
Could be. Or sentences, or even smaller units depending on the strategy. Each chunk becomes an item in your knowledge library that the RHG system can search and retrieve individually. Think of it like cataloging articles in a journal, not just the whole journal issue as one big blob.
Why is this so vital? You mentioned a Goldilocks problem.
Exactly. You need the chunk size to be just right. And getting it right or wrong directly impacts things like search relevance, cost, speed, and even hallucinations.
How so? What happens if chunks are too big?
If your chunks are too large, say whole chapters, they might contain the relevant sentence you need, but also tons of irrelevant stuff. This noise can confuse the retrieval system, making the search less precise. Bigger chunks costs more in terms of computation, and weirdly can sometimes lead to more hallucinations because the LLM has too much unrelated text to sift through when generating the answer.
Right, too much noise, so smaller is better.
Not necessarily.
Yeah.
If chunks are too small, like individual words or very short phrases, they might lack sufficient context for the system to understand their meaning properly within the document.
Ah, you lose the surrounding information that gives meaning.
Exactly. This can lead to less comprehensive answers. And you might end up with millions of tiny chunks, which can increase storage costs and potentially slow down retrieval in different ways. So it's a balance.
A critical balancing act, then. What influences the best way to chunk? Does it depend on the document?
Absolutely. The structure of the text is a huge factor. Well, for legal documents, maybe you want really specific clauses, so chunking by sentence might be best. For research papers, where each paragraph usually explores one idea, chunking by paragraph makes a lot of sense.
And for something like computer code?
You'd probably chunk by functions or classes to keep those logical blocks of code together. For tables in a document, chunking by rows often works well to keep the data relationships clear.
Okay, structure matters. What else?
The LM itself matters. Specifically, its context window, the maximum amount of text it can handle at once, measured in tokens.
Tokens being like words or parts of words.
Roughly, yeah. So if an LLM like GPT 3.5 has a context window of, say, 4096 tokens, your chunks need to comfortably fit within that limit. Too big, and they get cut off, losing information.
Got it. Keep it within the LLM's memory limit. Anything else?
The type of questions you expect people to ask is also important.
How so?
If you expect simple, factual questions, what's the capital of France? Smaller, very precise chunks might be optimal. But if you expect more complex analytical questions, analyze the impact of factor X on factor Y based on this report, you might need slightly larger chunks that provide more context for the LLM to synthesize a thoughtful answer.
Right, matching the chunk size to the likely query complexity. Okay, makes sense. So how do we actually do the chunking? What are the techniques?
There are several ways to slice and dice. The simplest is the character splitter. It just cuts the text based on specific character count or a simple separator like a new line.
Sounds basic, and maybe a bit clumsy.
It can be. It's easy, but often cut sentences right in the middle, which isn't great for meaning.
Okay, what's a smarter way?
The recursive character splitter is much better. It tries a list of separators in order. Like it first tries to by double new lines, paragraphs, then single new lines, then spaces, then characters as a last resort.
So it tries to respect the document's natural structure more?
Exactly. It prioritizes keeping meaningful units together, like paragraphs or lines, before resorting to just splitting by character count.
What if you absolutely want to keep sentences intact?
Then you use a sentence splitter. Tools like NLTK or Spacey can reliably detect sentence boundaries, ensuring your chunks are always complete sentences. This really helps the LLM understand the full thought.
Okay, that makes sense for preserving grammatical meaning. What about semantic meaning? Grouping related ideas.
Now you're talking about semantic splitting. This is more advanced. It uses embedding models, the same kind used in ARG retrieval, to figure out which sentences are conceptually similar.
So it groups sentences based on what they mean.
Precisely. It creates chunks where the sentences within each chunk are closely related in meaning, even if they weren't originally right next to each other in the text. It's powerful for capturing thematic context.
Wow. And what about really tricky documents? PDFs with tables, images with text inside.
For those complex formats, you often need document-specific splitting. There are libraries and tools specifically designed to parse PDFs, Word docs, even images or code files.
They understand the layout.
Yeah, they can intelligently identify and extract different elements, paragraphs, titles, lists, tables, figures, and chunk them appropriately. Imagine pulling a table from a PDF and keeping its row-column structure intact as a chunk. That's the goal.
That's incredibly useful for real-world, messy documents. Okay, one more. Can the LLM itself help with chunking?
Yes, it can. This approach is sometimes called LLM-based chunking, often focusing on extracting propositions.
Proposition.
A proposition is defined as like an atomic expression of fact, a single, distinct, self-contained statement. Instead of using rules like sentence boundaries, you prompt the LLM to read a piece of text and break it down into these minimal, factual units.
Okay, give me an example.
Sure, take this text. The dog, a classic domesticated animal, likely followed a commensal pathway to domestication. Questions about when and where this happened have puzzled geneticists and archaeologists for decades. Genetic studies suggest it started over 15,000 years ago from wolf populations in Europe, the Arctic, or East Asia.
Right, a dense bit of info.
An LLM doing propositional chunking might break it into statements like 1. The dog is a classic domesticated animal. 2. The dog likely followed a commensal pathway to domestication. 3. The timing of dog domestication has puzzled geneticists. 4. The location of dog domestication has puzzled archaeologists. 5. Genetic studies suggest domestication started over 15,000 years ago. 6. Domestication involved wolf populations. 7. These populations were in Europe, the Arctic, or East Asia.
Wow, it really pulls out each individual fact. That seems incredibly precise for retrieval.
It can be, yes. Each chunk is a very clean, focused piece of information.
This has been fascinating. We've gone from understanding LLMs and their quirks.
Their blind spots and hallucinations.
Right. To seeing how RAG provides that crucial external knowledge, making them so much more reliable and usable.
Using that three-step process. Encode, retrieve, augment.
And then we explored all those different coaching styles, the prompting techniques like chain of thought, thread of thought, chain of note, verification.
Even emotion and expert prompts.
Yeah.
Ways to really guide the LLM's output.
And finally, digging into the absolutely critical foundation, chunking, how breaking down that huge document effectively is key to everything else.
It really is. Understanding these concepts, from the high-level RAG process down to the details of chunking and prompting, really empowers you, doesn't it? You're not just throwing questions at a black box anymore.
No, you're actively shaping how the AI accesses and uses information. You're
Yeah.
guiding it to unlock knowledge specifically for your needs, turning that mountain of data into something actually useful, into real insights.
It's about moving from just using AI to effectively collaborating with it.
Well put. And thinking ahead, as these AI models get even more powerful, our ability to structure the data we give them and to ask the right questions in the right way, that really feels like the crucial skill.
Absolutely. Prompt engineering and data preparation are becoming core competencies.
So a final thought to leave our listeners with. As we develop these increasingly sophisticated ways to coach AI, what new interaction styles might be next? How might we communicate with these powerful tools in even more intuitive, maybe even more human ways in the future?
That's the big question, isn't it? Exciting times ahead.